We'll start in 1 minute. In a few minutes, we'll look at section 3.1, part B, on graphing linear equations with intercepts. But first, we'll finish 3.1, part A. So we did the first two. We checked we checked two of these ordered pairs in the equation to determine if they are solutions. So the procedure, if you want to test an ordered pair to see if it's a solution, you replace the variable x with the x coordinate and replace the variable y with the y coordinate. If the resulting equation is true, then you know that you have a solution. So let's test the ordered pair -10, -7 in the equation 5x plus 9y equals 4. So replace x with -10. So we have 5 times -10. Replace y with -7. So we have 9 times -7. And we want to know if the left-hand side is equal to the right-hand side. So simplify. 5 times -10 is -50. And we're adding -63. And this is going to be clearly false. -113 equals 4. That is false. So that means the ordered pair -10, -7 is not a solution. Hey, let's test one more. The other ordered pair, 5 for x and -7/3 for y. So we'll move it down here where we have a little more space. So in the equation 5x plus 9y equals 4, we're going to replace x with 5. So 5 times 5. And we're going to replace y with -7/3. So we have 9 times the fraction -7/3. And we'll check to see if that's equal to 4. 5 times 5 is 25. 9 times -7/3. Remember, one way to multiply two fractions is to look for common factors. So 3 goes into 3 once and into 9 3 times. So we have plus 3 times -7, which is 25 plus -21 equals 4. And that is a true statement. Okay, so to reiterate, the ordered pairs 7, -31/9, and 5, -7/3 are solutions. So I'll write that down here. The ordered pairs 7 for x, -31/9 for y, and the other ordered pair 5 for x and -7/3 for y. Both of those are solutions. to the equation 5x plus 9y equals 4. Okay, what does that mean graphically? Well, if we were to graph that linear equation, then these would be two of the points on the line, two of the infinitely many points. Okay, let's graph this equation. Graph the equation 4x plus 2y equals 2. Okay, so if we pick an x value, we can use the equation to find the y value, and that will determine the ordered pair of one of the points. Remember to graph the equation of a straight line, all you need are two different ordered pairs. So I'll pick x to be 1. I have infinitely many choices, but I just decided I want to pick x to be 1. So replace x with 1, 4 times 1 plus 2y equals 2, and do the arithmetic. 4 times 1 is 4. Plus 2y equals 2. Let's subtract 4 from both sides, so we get 2y equals negative 2. And then divide both sides by 2, we get y equals negative 1. Okay, so one of the points on the line is the ordered pair 1, negative 1. This time, I'll pick y to be 1. And then in the equation, replace y with 1. So we get 4x plus 2 times 1 equals 2. And then solve for x. Subtract 2 from both sides, we get 4x equals 0. And so the x coordinate is 0. So the ordered pair 0, 1 is another point. So if we plot those 2 points, 1, negative 1, and the ordered pair 0, 1, then we can draw a straight line through those 2 points. Okay, the next one, graph the equation y equals x divided by 2 plus 4. Okay, find 2 ordered pairs of points on the line y equals x over 2 plus 4. I'll give you 20 or 30 seconds to come up with a couple of ordered pairs. So while I wait, I'll sketch in the x and y axes. Okay, that probably gave you enough time. What's one ordered pair? Okay, I have an answer online. So if we pick x to be 0, then y equals 0 divided by 2 plus 4, or 4. So the ordered pair 0, 4 is a point on the line. That's this point, 0, 4. Another ordered pair, a strategic move. Notice we have x divided by 2. So if I pick x to be a multiple of 2, it makes the arithmetic easier. So the multiples, the positive multiples of 2 are 2, 4, 6, 8, 10, and so on. The negative multiples of 2 are negative 2, negative 4, negative 6, and so on. So the one suggested online is to pick x to be 2. And so y equals 2 divided by 2 plus 4 equals 5. So the ordered pair 2, 5 is a point on the line. So 2, 5 is about right there. Let's try, even though we have enough, we have all we need are 2 ordered pairs. Let's find another ordered pair. This time pick x to be negative 4, say. So find the y coordinate that goes with the x coordinate negative 4. So we can do the work down here. Y equals, replace x with negative 4. Y equals negative 4 divided by 2 plus 4. Negative 4 divided by 2 is negative 2, and negative 2 plus 4 is 2. Okay. So negative 4, 2 is right here. So they all should be on the same line. And my graph is sort of believable that that's all a straight line. Okay, now we'll go ahead and move on to the next section. Well, it's Chapter 3, Section 1, Part B. Okay, so starting at the top, every straight line in the xy plane that is not vertical and not horizontal intersects the x-axis at exactly 1 point, and it also intersects the y-axis at exactly 1 point. The x-intercept of a line is the point on the x-axis where the line intersects. And the y-intercept of a line is the point on the y-axis where the line intersects. So answer this question. This problem here, every x-intercept has a y-coordinate that is blank. Fill in the blank. So remember what an x-intercept is. Above here is the definition of the x-intercept. If you graph a line and if it intersects the x-axis, then that point is called the x-intercept. So every x-intercept has a y-coordinate that is what? What number?
Is it 0?
Yeah, the y-coordinate is 0. Every x-intercept has a y-coordinate that is 0. It's a small detail, but if you forget it, it can cause you heartache. Every x-intercept has a y-coordinate that is 0. So we've already seen that. I pointed that out yesterday. And analogously, every y-intercept has an x-coordinate that is 0. I'll just illustrate that here. Suppose we have a line that passes through these 2 points. So pretend like that's a straight line. So in this little graph, this point right here on the y-axis, it's a point on the line. So that is the y-intercept. The other point on the line is on the x-axis, so this is the x-intercept. So we can tell what the ordered pair is of the y-intercept. What's the ordered pair for the y-intercept?
3, 0.
0 for x and 2 for y. An ordered pair has 2 numbers separated by a comma and surrounded in parentheses. So the ordered pair for the y-intercept is 0, 2 in parentheses. The x-coordinate of the y-intercept is 0. The other point is the x-intercept. What's the ordered pair for that point?
3, 0.
Yeah, 3 for x and 0 for y. So the y-coordinate of the x-intercept is 0. Okay, that's always going to be the case. So remember that. Okay, so let's graph some equations by plotting the intercepts. Graph the equation negative 2x minus 4y equals negative 4 by plotting the intercepts. That means by plotting the x-intercept and the y-intercept. Okay, let's find the y-intercept first. What's the ordered pair for the y-intercept? I'll give you 10 seconds to figure that out. So you can type the ordered pair in on YouTube if you find the Y-intercept. And then find the X-intercept. And once you know the X-intercept and the Y-intercept, then you can plot them in the XY plane and draw a straight line through them. Okay, I have an answer online. Okay, so with some practice, you'll learn how to graph straight lines by plotting the intercepts. With practice, you'll be able to do it in 10 seconds or thereabouts. So if we want to find the Y-intercept, what do we remember? We remember that every Y-intercept has an X coordinate of 0. And then in the equation, when you replace X with 0, we're just left with negative 4y equals negative 4, or y equals positive 1. So the Y-intercept is the ordered pair 0, 1. To find the X-intercept, we remember every X-intercept has a Y coordinate that's equal to 0. So this time in the equation, replace y with 0, and we're left with negative 2x equals negative 4. Divide both sides by negative 2, we get x equals positive 2. And so the ordered pair 2, 0 is the X-intercept. So we plot them. 0, 1 is right here. The ordered pair 2, 0 is right there. And then you can graph the line. Okay, that's all there is to it. So know this by heart. Every X-intercept has a Y coordinate that is 0. Every Y-intercept has an X coordinate that is 0. Okay, let's try it again. Graph the equation y equals x divided by 2 minus 3 by plotting the intercepts. Okay. If we start with the X-intercept, we remember every X-intercept has a Y-coordinate equal to 0. So replace Y with 0. 0 equals X divided by 2 minus 3. And solve for X. So we can add 3 to both sides. We get 3 equals X divided by 2. Then multiply both sides by 2, we get X equals 6. So the ordered pair 6, 0 is the X-intercept. Then to find the Y-intercept, we remember every Y-intercept has an X-coordinate that's equal to 0. And so in the equation, replace X with 0. So we can write Y equals 0 divided by 2 minus 3, which is 0 minus 3 or negative 3. So the Y-intercept is the ordered pair 0, negative 3. 0, negative 3. When you're quizzed and tested over graphing straight lines, whatever 2 points you find, make sure that you label the ordered pairs for those 2 points. Okay, the next one. Okay, so if online you've already answered a question, let someone else type in an answer. So let's graph this equation, negative 3x minus 2y equals 6, by plotting the intercepts. So we'll find the x-intercept and then the y-intercept. Okay, somebody who hasn't answered a question yet, type in the x-intercept. Or in class, you can go write it on the board over there so I can see it, if you find it. Okay, I got an answer online. So to find the x-intercept, what do we do to find the x-intercept? So to find the x-intercept, we remember the y-coordinate is 0. And so in the equation, replace y with 0. So we get negative 3x minus 2 times 0 equals 6, or 3x equals, sorry, negative 3x equals 6. Divide both sides by negative 3, we get x equals negative 2. Okay, so the ordered pair negative 2, 0 is the x-intercept. So label it negative 2, 0. Then to find the y-intercept, we remember that the x-coordinate is 0. So this time negative 3 times 0 minus 2y equals 6, or negative 2y equals 6, and divide both sides by negative 2, we get y equals negative 3. Okay, so the ordered pair 0, negative 3 is the y-intercept. And then draw a line through the 2 points. Okay, on the next page, graph each of the following lines using any method. So we'll start with this one, y equals 4/3 x minus 4. Okay, we can find any 2 ordered pairs that you want, preferably ones that are convenient to plot in the xy plane. One way to think of an equation in 2 variables, like this one, y equals 4/3 x minus 4. Think of it as a formula for finding, say, the y-coordinate whenever you pick an x-coordinate. So this is all set up for that. If we pick x to be any number we want, then we can do the arithmetic to find the corresponding y-coordinate. So it's a formula for finding coordinates. Okay, so online, 5 different people have answered questions. How about somebody else? What's one ordered pair on the graph?
Do X is 3.
Pick x to be 3? Okay. So if we pick x to be 3, then use the formula for finding the y-coordinate. Y equals 4/3 times 3 minus 4. 4/3 times 3 is 4. So we get y equals 4 minus 4, or 0. So the ordered pair of 3, 0 is a point on the line. Hey, what's another point?
Said X equals 0.
Okay, you can pick x to be 0. So 4/3 times 0 minus 4 is 0 minus 4, or negative 4. So we found the intercepts. So as long as you have 2 different points, that's all you need. So the ordered pair 3, 0, and the ordered pair 0, negative 4. And then draw a straight line. Okay, the next one, 3x plus 4y equals 11. So we just want to find the x and y coordinates of 2 points. Well, this one, it's sort of a challenge to avoid fractions. But fractions are numbers. So how about if we just use the x and y intercepts? So if we pick x to be 0, then 3 times 0 plus 4y equals 11, which is 4y equals 11, so y equals 11/4. So that's a number that's 2 3/4, 2.75. So we can try to plot that. Then find the x-intercept by picking y to be 0. So when y is 0, 3x plus 4 times 0 equals 11. So x equals 11 thirds. So the ordered pair 11 thirds 0. Okay, so 0 and 11 fourths. So that's the y-intercept. So if you get it in the ballpark, and then just label it 0, 11 fourths. And then 11 thirds 0. Well, that's 3 and 2 thirds. So right in there somewhere. And then draw a straight line. So pretend like that's a straight line. Okay, let's do this last one. Negative 2x equals 5y minus 10. Okay, open season. Anybody can answer, even if you've answered half a dozen questions already. Find one ordered pair on the line.
So X would be 5 and Y would be 0.
Okay, if x is 5, y is 0. So we can test that. So down here we'll test the ordered pair 5, 0. So negative 2 times 5 equals 5 times 0 minus 10, or negative 10 equals 0 minus 10. That's true. Okay, so one ordered pair is 5, 0. So what is that? What's the name for that point? The what?
The X-intercept.
Yeah, it's the X-intercept. Yeah, we found the X-intercept. Okay, one other point.
Zero, 2.
Okay, yeah, 0, 2. When x is 0, the y coordinate is 2. Let's go ahead and test it. Test the ordered pair 0, 2. So in the equation, negative 2 times 0, is that equal to 5 times 2 minus 10? 0 equals 10 minus 10. That's true. So the y-intercept, oh, darn, I gave it away. Anyway, 5, 0. And 0, 2. And then sort of a straight line that passes through them. Okay, we have a few minutes left. There's there's a couple of problems from a few days ago that we can look at. So this is from chapter 2, section 7, part B, on absolute value inequalities. So we can work on solving these two absolute value inequalities, and we'll write the solution in algebraic notation and interval notation. Okay, so this one, the absolute value of 5y plus 2 plus 4 is less than 13. So the first thing we do is get it into standard form. The absolute value of 5y plus 2 is less than 9. Okay, so if the absolute value of 5y plus 2 is less than 9, then without the absolute value symbols, we can write a compound inequality. Negative 9 has to be less than 5y plus 2, which is also less than 9. Okay, then we'll solve this compound inequality. We want y to be by itself in the middle. So first, subtract 2 from each of the 3 parts. Negative 9 minus 2 is negative 11. 5y plus 2 minus 2 is 5y. And 9 minus 2 is positive 7. Then we divide each of the 3 parts by positive 5. And we get negative 11 fifths is less than y, which is less than 7 fifths. Okay, so this is the algebraic notation. And then the interval notation, we put a left parenthesis, negative 11 fifths, comma, 7 fifths, right parenthesis. This is the interval notation. So I'll just make a comment about this. If you think of 5y plus 2 as a number, if the absolute value of a number is less than 9, then no numbers can break out to the right towards infinity or to the left towards negative infinity. So they have to stay in a certain interval because their distances are always less than some positive number. Okay, let's work on the next one for a minute or so. 3 times the absolute value of 4y minus 3 is greater than or equal to 15. First, divide both sides by 3. So we get the absolute value of 4y minus 3 is greater than or equal to 5. So when we write, on this one, when we write the inequalities without the absolute value symbols, one of those is 4y minus 3 is less than or equal to negative 5. And then we write or 4y minus 3 is greater than or equal to 5. So the idea here is if the absolute value of a number is greater than or equal to 5, Well, it can't get very close to 0. It has to either be to the left of -5 or to the right of +5. But then solve each of those, add 3 to both sides. We get 4y is less than or equal to -2. Divide both sides by 4. Y is less than or equal to -1/2. Solve the other one by adding 3. We get 4y is greater than or equal to 8. That becomes y is greater than or equal to 2. Okay, so this is the algebraic notation, and I'll quickly write down the interval notation. Y less than or equal to -1/2. That's -infinity, comma, -1/2 bracket, and then union, the other part, bracket 2, comma, infinity. Okay, we're a little over time, so go ahead and sign in online for attendance. Victor. Nicholas. Melissa. And Richard. Okay.